Hello, geometry friends. Here we are in chapter 11. We're looking at section 11.3, and we're going to be talking about areas of circles and sectors. Our vocabulary consists of two words, or two phrases rather, the sector of a circle, and then we have something called the segment of a circle. So if I have a circle, see if I can draw a nice one here. Not that one. If I have a circle and I consider the idea of like a slice of pizza, right? What the textbook says is you've got two radii intersecting with a central angle between them, intersecting the sides of an arc that's either major or minor. Okay, I'm just going to call it a slice of pizza, but I think you guys understand both definitions. So if we have this slice of pizza, this area here is considered the sector. All right, so it's kind of like a slice of pie. If we then take that slice of pizza and cut straight across from intersection point to intersection point, and let's color that this color, I suppose. No, let's use that. Okay, if we color it that way, this portion is considered the segment of the circle. And before we move a little bit further, I'm just going to recap something that I know you guys remember from before. The area of a circle is equal to pi r squared. The area of a sector is going to be a fraction of that. So it's going to be pi r squared times some fraction, because this pi is a slice or a fraction of the entire circle. This slice of pie is a fraction of the entire circle, excuse me. So what's the fraction? Well, the fraction will be, we'll use the central angle, x degrees over 360 degrees. So whatever that central angle is, that's going to give me the power to find the fraction that I can use in order to find the area of the sector once I have the area of the circle. And if I had to find the segment of a circle, the area of that segment, I would need the area of the sector, and then I would have to subtract out the area of the triangle that is adjacent to that particular circle segment. All right, hopefully that makes sense. Let's go on to some examples. Okay, so here in example one rather, the area of a circle is what we're after here. What is the area of the circle? A circular putting green shown to the nearest square foot. We see that if the diameter is 20, then the radius is 10, recognizing that the area of a circle is equal to pi r squared. We simply recognize that we have pi times 10 to the second power, or 100 pi. I like leaving it in that answer because it's like exact, but if you're kind of into decimals, I would say 100 pi feet squared, but if you're into decimals, you can change your pi to 3.14 and you get 314 feet squared. So for example 2, we're going to use the area of a circle to find a missing measure. Now we're going to find the radius of a circle with an area of 95 square centimeters. So we remember the formula from last time. The area is equal to pi r squared. And so we know that 95 is our area. What we would need to do is divide both sides by pi, because it's not a variable, it's a number, right? So 95 over pi is equal to r squared. And how do we undo that mess? Well, we take the square root of it. Usually when we take the square root of something solving for a squared variable, we do plus or minus. But given the fact that we're talking about a real world situation, we know we're not going to have like a negative length when we're talking about the area of a circle. So I'm going to take the square root of 95 over pi without the plus or minus, and I recognize that's my answer for r. I wouldn't leave it this way because it's just not really a convenient answer. So I'm going to consult my calculator and I'll be right back. So I ended up getting 5.499, which is basically 5.5 centimeters for the value of the radius. Let's take a look at this final example. Such a short video, I know. Okay, so the area of the sector of a circular pizza has a diameter of 12 inches and it's cut into 8 congruent slices. What is the area of one slice to the nearest hundredth? Well, we remember to find the area of a sector, we need to first find the area of the circle, and then we're going to multiply it by a special fraction. x degrees over 360, where x is the central angle. And so the area is pi r squared times this little fraction. That's going to be our friend. Okay, so what is the radius? The diameter is 12, so the radius must be 6. So we get 36 pi by squaring that 6 squared times 6 times 6, 36 pi. And now we need to figure out what this angle is here. So I recognize that we're cutting the pizza like many people do into 8 equivalent slices, or approximately equivalent. And so what is the x value? The x value is going to be determined, assuming that the slices are congruent, is going to be determined by saying, hey, if I've got 8 slices and 36 pieces, I'm just going to have to divide 300, I said 36 pieces, I said it and I heard myself. If I have 8 slices and those 8 slices all make up 360 degrees, I'm getting myself together, we're going to divide 360 by 8. And when I do that, 360, 8 goes in 364 times. I know you did it faster than me, Charlie. And then I'm still trying to get the next part. And then I know now all of you have like done 245, 45. Thank you, babies. And then so 36 pi times 45 over 360 is the way we would do it. Honestly, now that I did that, and I'm sure somebody in there is like talking to me and saying, see, you should have just did it differently. If it's 8 equal slices, that means that this fraction was just 1/8. My bad. So then it should have just been 36 pi times 1/8, because that's what this would reduce to anyway. I'm learning, babies. So 8 goes into 36, not evenly. It goes in, we'll kind of saw that here, 4.5 times. So the answer literally is 4.5 pi, or you could write that as 9 over 2 pi. Or we can take a calculator break. And when we do that, we get 14.14. They did say rounded to the nearest hundredth. 14.14 inches squared. So that's the area of our slice of pizza. And that's the end of our lesson. I hope it made sense. Let me know if you have any questions or issues, and especially with the assignment. Take care, guys. Bye-bye.